Hello there. Welcome to our today's science lesson. The topic for the day being more about mixtures and pure substances. In our previous lesson, we looked much more into what is an atom, what is an element, what is a compound, what are molecules, how are they formed, the differences between an element, a molecule, and how the so many particles, either as as elements or molecules, can be used to form compounds. Now we need to realize that from that very lesson, when we talked about an element, this was a substance that had been formed by using same type of atoms. Since the type of atoms that were being used are the same, then we can use a different word to describe this, which is in terms of either being pure or impure. So if they are the same, the only ones present forming one substance, what we are calling an element, then we can say this is a pure substance. That is a pure substance. Atoms of the same type forming one substance, which we are calling an element, that substance will be pure. Just like what we did at that time, we can describe these using different boxes, shapes, or color. So if there are boxes, I can say this is an element. Why? Because the boxes I'm using, or the shape and the color is the same. If in case I will draw the same but using now black, then that ceases to be a pure substance, because I've introduced in a different type of atom. So when you talk about a pure an element is a pure substance made of same type of atoms. You can also talk about a pure substance which is a compound. A pure substance which is a compound. How can a compound be pure? This exists because you can have combined this one and this, but they are the only ones present. There is no any other. In that particular substance or vessel, container, whichever part you are talking about, that is the only combination of atoms you are seeing. They have formed molecules. Remember, we said a molecule is the simplest compound. So long as it has two atoms and more, the atoms can be of the same type or different, but so long as there are two and more, then there's a compound. So if this is a compound being formed by two atoms and they are the only ones present, we are not trying to introduce another one. For example, this one. If I do that, then I will have introduced two other different molecules. This one ceases to be a pure substance. But if it is just as it is up here, then we can say this is a pure substance of that particular molecule. Pure substance of that particular molecule. Take an example of, if I can say oxygen gas. I can say this cylinder is carrying a gas, and this gas is pure, and the name of the gas is oxygen gas, pure. This is a cylinder carrying a gas by the name hydrogen. This is a pure gas of hydrogen gas, a pure gas of carbon 2 oxide, a pure gas of carbon dioxide. It is a compound, yes, but that is the only compound present in that particular container holding that particular substance. It can be even a very big substance. Look around. Look at probably the seat you are seated on. If it is made of wood, you can say this is wood of a particular tree. But wood is a compound. But you can talk of a pure substance of that particular tree. Why? The characteristics of all the parts of that wood is in relation to that particular tree. Look at a metal. That's a compound. But that compound is made up of a small particular substance, one particular substance. That's why a compound can also be pure. But in our daily lives, you will always find elements of particular substance or atoms mixed with the others that can now be split by physical means. We are now introducing here another aspect, being able to separate whatever you have together by physical means and not just chemical means. Chemical means we will be talking about a compound. Now we are talking about physical means. Then what shall we be having? We shall be having what we call a mixture. We are now talking about a mixture. So a mixture can be a combination of elements or elements with the compounds or compounds. Elements, for example, I can have a mixture of helium, which is an element, being mixed with another element, maybe argon. These ones can be separated by physical means. Just look at probably melting point, boiling points, and using different boiling points, they can easily be separated through distillation. When liquefied, then you distill, you'll have gotten distillation is a physical process. It's not a chemical process because it just involves heating, looking at physically the thermometer, at what temperature is it reading. Once the temperature of a particular species or substance you want has reached, then start collecting that. That's a physical process. So you can be able to separate this. These are atoms of an element by the name argon and helium. So here you are talking about elements of the same type, but forming a mixture which can be separated by physical means. Why did you choose on distillation? You chose on distillation by looking at the characteristics, the properties of each one of them. So when you are talking about a mixture and the separation of mixtures, the one aspect you must just know is look at the properties of each of the component in the mixture first. Compare them. Then choose the best way to go about to solve the case of the mixture. What can I apply so that this one is not interfered with, but I can get this one out? And that is what we are going to look at in the course of the lesson. The other mixture can be you have a compound. I can have a compound of oxygen gas plus argon gas plus nitrogen gas, famously known as fractional distillation of liquefied air. You want to get nitrogen gas from the atmosphere, or you want to get oxygen gas from the atmosphere. What is air? Air from the atmosphere is a mixture, which is a mixture of so many components. And some of those components are oxygen, argon, and nitrogen gas, plus others. Now, if you want to get any of these three, what can I do? Do I have to apply a chemical process? The answer is no. You apply a physical process by the name distillation, particularly fractional distillation, because their boiling points are relatively close to one another. If they are wide apart, like if you are talking about separation of a compound like water, remember this is also another example, water and ethanol. If I have water as a compound, remember we have said that a mixture can be compound plus compound, or element plus compound, or element plus element. So this element plus compound, element plus compound. This was element plus element. Now we want to look at compound plus compound. Water plus ethanol is a compound because water is this way plus ethanol is C2H5OH. So this is a compound. You can see it has 2 hydrogens, 1 oxygen, 2 carbons, 6 hydrogens, and 1 oxygen. And all of them put together, they will not react. You will only be diluting the ethanol. It will only be dilute, but not that they have reacted. So being that they haven't reacted, meaning that water is on its own, ethanol is on its own, the only change you have done is changing the concentration of the ethanol, then it means it is possible for you to separate these two substances. Then how do you go about this? You can still use distillation. Why? Because you will have looked at the properties of water and the properties of ethanol and realize that water at sea level can boil at 100 degrees centigrade and ethanol at sea level can boil at 78 degrees centigrade. Being that their boiling points are far apart, you can use what we call simple distillation, and these ones being close, you can talk about fractional distillation. All in all, they are all distillations. So we have seen a mixture can be made of atom plus element plus element, which is made of particular atoms, and the atoms here are different. They can also be made of atoms which are of particular elements and compounds. These molecules are just compounds. So atoms and molecules forming a mixture, or compound and compound forming a mixture. But as I've just said, for us to separate these mixtures, put into consideration their properties. And each component having particular characteristics will always fetch a particular type of method for separation. So I want us to look at examples in terms of colored or different shaped structures representing mixtures and see if we can be able to identify whether that is a mixture. That's number one. And number two, the probable ways we can use to separate that mixture. So number one, identify for me whether the drawing is a mixture or a pure substance. We have two cases here, and the question is, identify which one is a pure substance and which one is a mixture and why. Look at one. One is having all circles in one big box. Could this be a pure substance or not? The answer is this is a mixture. Why a mixture? Because even if there are all circles, these three circles are red, meaning that they stand for a different type of substance. It can be an element or it can be a compound, but it is different from these others. Looking at case 2, this is a pure substance. Why? Because all the 9 circles are of the same shape and the same color. Let's look at case number 3. Case number 3. The same question applies. Identify if 3 or 4 are pure substances or mixtures. Let's start with the number 3. Is this a mixture or a pure substance? And maybe to add some weight on the question, if it is a mixture, is it a mixture of a compound or an element? And if it's a pure substance, is it of an element or a compound? And the same to question 4. Looking at 3, first of all, to see whether the small components inside are either an element or a compound, these ones are compounds. Why compounds? They are different from these ones where we can assume this was just one particular element. So this one was a mixture of elements, and this one was a pure substance of elements. This one is a mixture of compounds. Why? Looking at the components of the mixture, they are made of different shapes, meaning that these are different elements and these are different from these. Again, these are different colors, so meaning that they stand in for different elements, giving us an overall answer of a mixture of compounds. But this one was a mixture of elements. Now, how can you separate this? You will have to look at the property of this and this separately, independently. Then look at the best method you can apply, which can either, first of all, give you, at least when you are separating, one comes out before you get the other one. So you choose one, a method that will give you one as you wait for the other one to come next. Looking at case 4, these are 2 compounds. These are compound because you can see the shapes are different. We have a square and 4 triangles, a square and 4 triangles. But again, these ones are not the same. The compounds are different because as you can see, this one is a square, these are square, yes. But look at the triangles. These are red and these are black in color, meaning that they are of different elements. Take an example of maybe this one is a carbon and these are 4 hydrogens and this is carbon and these are 4 chlorine atoms. The 2 compounds will be totally different. Now, how do you separate again this? You have to look at the properties of the 2 compounds, forming forming the components of that particular mixture, and choose on the particular method that will favor each one of them being separated. Let's look at even more examples. So we have another one here as number 5. Try to think of it if it is a pure substance or a mixture. Then we can also have 6. Think of it, is it a mixture or a pure substance? Get a good look of the diagrams. Identify the components. First of all, are they elements or compounds? 2, is it a pure substance or a mixture? Starting with the number 5, the components are not elements. The components are compounds. The small components making the mixture, the whole of this is the mixture. So the small components we have in the mixture are compounds. Why are they compounds? Because each component is made of more than one atom. Anywhere you get more than one atom, then that is a compound, so long as it's chemically combined. So these are chemically combined, forming a compound. Now look at the compounds. Are they the same? Yes. The 4 we are having inside here are the same. This shows that even if they are compounds, but they are forming a pure substance. They are forming a pure substance. An example here, if you can assume this square is carbon and the triangles are hydrogen, then we can say this is a container holding a gas by the name methane gas, lab gas, natural gas. It carries all those names: lab gas, natural gas, cooking gas, methane gas. They all mean the same. So you can talk of this is a pure substance which is called natural gas or methane gas. Why? Even if it is a compound, they are the same compounds just together forming that particular substance, which can be a gas, a liquid, or a solid. Looking at number 6, identify first of all the type of small units in it. How many types are we having? They are 3, namely 1, 2, and 3. This one is, they are all black, these ones are all red, and these ones are red and black. Now, again, red and black, they are all triangles. They are all triangles, but others are a triangle and a circle. All these represent different elements. They can be of the same shape, but being red and black will stand in for a different element. So in essence, we are having a mixture of 3 components. A mixture of 3 components. These components are not an element, they are compounds, because each one of them is made of more than one atom. So we form compounds. We have compounds which are together to form a mixture. And for us to separate the mixture, then we have to look at each property, each component's property, so that we see, are we supposed to first of all add in water, maybe to dissolve one of them, then filter? Will all depend on the property of that particular component in that particular mixture. Now let's look at also maybe a different format of a question, just to look at what we have been talking about in this lesson. In your own words, we have talked so much about this. In your own words, define a pure substance and a mixture. We have just been drawing, talking about it, describing it, in fact with the drawings, but in each of them I was mentioning either a mixture or a pure substance. Now in your own words, describe or define these terms, pure substance and a mixture. Let's start with a pure substance. So we define what is a pure substance. Now we need, first of all, as we define, you have to reflect on what I've been mentioning. And what did I mention? A pure substance can be made of either elements or compounds. 2, the elements, if there are elements, they must be of the same type of atoms. And 3, if they are compounds, the compounds must be of the same compound. All of them. So what's a pure substance? A pure substance is any substance that is made up of either elements of the same type or compounds of the same type. A pure substance is any substance that will be made of elements of the same type or compounds of the same type. Going back to the drawings, a pure substance is any substance made up of same elements of the same atom. Can talk of this. These are the same. Same color, same shape. So these are elements of the same type, forming a pure substance. An example was, if I can talk of helium gas, that will be a pure substance, helium gas, because we are only talking about helium atoms in that gas, giving us a pure substance made up of the same element. And that element obviously will be made up of a particular atom. An example here was helium. But we have also said a pure substance can also be made of compounds of the same type. compounds of the same type. We can talk of molecules. For example, if I can have oxygen as a good example of a molecule. Here we are having a compound. Why a compound? Because two atoms have come together to be chemically combined. So that's a compound. But that is the only compound present. This and this and these are the same. Two atoms of the same type, two atoms of the same type, two atoms of the same type together forming oxygen gas. This was a helium gas and this one is a oxygen gas. So here we can say this is a pure substance made up of a compound by the name oxygen gas. A pure substance made up of same type of elements or atoms by the name helium gas. So that is, in our own words, defining or stating what is a pure substance, being made up of same type of elements or same type of compounds. How about a mixture? Mixture. What is a mixture? Now, when it comes to a mixture, you still talk about elements and compounds. But here, the difference will be when you are talking about a mixture, this is a combination of two different things, but that can be separated by physical means. So in our own words, we can say a mixture is a combination of two or more substances that can be separated by physical means. The substances can either be made of elements or compounds. The substances that are to be separated can be made of elements or compounds. Giving an example here, you can have a mixture of those two. So as much as there are elements, but they are making a mixture. There are elements that are different. This one is different from this. So being that way, then we can say these are mixture and we can be able to separate the two by physical means. Where I gave an example of if I have argon and helium. Those are atoms of atoms of argon, atoms of helium, which are obviously elements and they are different and they are making a mixture. They can be easily separated by physical means. You can also talk about atoms and compounds. So this is also a mixture where you can see an atom being mixed with a compound. It still forms a mixture, a combination of two or more substances that can be separated by physical means, or two or more substances that have different properties and can be separated by physical means, have different properties and can be separated by physical means. The property of these and these are obviously different, just like these and these are different. A good example here being if I have argon, I have argon here, and maybe this one is oxygen, and you want to do what we call fractional distillation of liquid air. You can separate the two using fractional distillation. Why? They have different properties. Oxygen gas, argon gas. We can also have a mixture of compounds. I can have this and this mixed. So looking at them, these are totally two different things, but they are all compounds. Having different properties, then they will always give different ways or methods on how they can be separated. and qualifying it to be a mixture. So what's a mixture? It's a combination of two or more substances that have different properties and can be separated by physical means. As an exercise to maybe make you be on toes, I would like you to draw 5 diagrams. And in the 5 diagrams, so you draw 5 diagrams. And in the 5 diagrams, diagram number 1, it should have 5 compounds, giving us a pure substance. That's number 1. 5. In that diagram as you have drawn, let's see 5 compounds, but that 5 compounds gives us a representation of a pure substance. Number 2, draw again 5 compounds, but that 5 compounds is giving us a mixture. 3, 5 components, 5 components of an element but mixture. 4, 5 components of an element but pure. And lastly, 5, you draw again 5 components of element and compound and state. And state if it's a compound or mixture. So here are 5 questions. Each one of them you are going to draw, and in your drawing, question number 1, 5 compounds, but they have to represent a pure substance. 5 components, a mixture. 5 components of an element but mixture. 5 components of an element but pure. And this number 5 is a bit unique, where we have 5 components of element and compounds, but after the drawing, state, is it a compound or a mixture, and explain. And you explain. So let's start with the number 5, and then number 1. Number 1, we are being told that we draw five compounds but representing a pure substance. In this question, it is open. You can use any number of the atoms. Remember, it's a compound, so it must be at least 2. So you can use 2, you can use 3, you can use 4, you can use 5, 10, so long as we're talking about a compound forming the smallest particle of that substance you are talking about, which is a pure substance. So for my case, I'm going to use 3. So that gives me one compound, but I've been told 5 of them, and they must be pure. So all of them must be the same structure, because here we are mainly talking about structures. 2, 3, 4, and 5. So this diagram is answering our first question, where we are seeing 5 compounds. They are in number 1, 2, 3, 4, 5, and they are representing a pure substance. They are of the same type. So meaning that a compound can also be a pure substance. Question 2. In question 2, it is asking us to draw 5 compounds, but giving us a mixture. 5 compounds giving us a mixture. This shows that we must have 2 or more different of them. They can all, the 5, be totally different from each other. And that is what I'm going to go in for. 5 of them, but different. So I will use this. Those are 4. Can also use this one so that we can see the love of our subject today, having 5 fingers. So this one you can have it having 5 fingers. So those are 5 compounds, but giving us a mixture. Looking at all of them, they are different. Different by structure. And being different by structure, automatically they are different by characteristics or properties. And therefore, when it comes to separation, they will obviously fetch different methods on how they can be separated. So these are compound, all of them, and giving us a mixture. Meaning that compounds can give us a mixture, just like compounds gave us a pure substance. For question 1, it was compounds giving us a pure substance, and in question 2, compounds giving us a mixture. Let's look at question 3. In question 3, we are looking at components of an element but mixture. So remember, we are talking about an element, not a compound. Question number 1, it gave us compounds but pure. Question number 2 was compounds but mixture. And here now, question number 3 is giving us element but mixture. This is the opposite of 2, where instead of talking about a compound, you are talking about an element, but still giving us a mixture. So here we can have so many of them. Have this. Can also have a different one. So those are drawings of elements. These are elements. As you can see, they are not combined with any other. They are just on their own. So they are elements. but as elements, they are not of the same shape. Having different shapes, it means they are atoms of different elements. These are atoms, but of different elements, meaning that they have different chemical properties. And having different chemical properties, they can be separated depending on those properties. So this one gives us a good example of components of an element, but giving us a mixture, which is different from components of a compound that were giving us a mixture, like the one that we have just seen in question number 2. Let's look at question number 4. Question number 4. Question number 4 is telling us to have components of an element but giving us a pure substance. Pure substance here is telling us that whatever you have must be the same. Pure means the same. We saw for the case of compounds, question 1, we drew compounds, but they were all the same, giving us a pure substance, a compound. Here we have to draw elements the same, giving us a sense of a pure substance. So let's have it pure. You can have it this way. So you can see those are 4. You can add here 51. There's a love sign. We love science. Science is life. What we are talking about is life. And in life we always separate things, and in separating we separate those compounds and elements. Separate pure and impure. So here we are talking about pure element. As you can see, the drawings are the same, but one, meaning that it is not a compound, but is an element. And since they are of the same type, then it is a pure type of an element. And lastly, let's look at question 5, which has 3 questions in it. Question 5 has 3 questions in it. Question number 1 in it being 5 components of element and compounds. We first of all draw. We draw 5 components, and these 5 components, some are elements and others are compounds. Let's first of all draw and see what the others will be. So what we are seeing is 5 different drawings, 1, 2, 3, 4, 5, and in each of the drawing there's something we can pinpoint. This is an element, an atom of an element, just one atom, an atom of an element, one atom, an atom of an element, one atom. In this one, we are having 2 atoms together. These 2 atoms are of different elements, but that one is not the issue. The issue is 2 atoms together chemically combined. What is that? That is a compound. There is a molecule, but a molecule which is a compound. In this one, we have 5 atoms together. 4 of them are of the same, and the other one is different. But what is important is the 5 have come together to form one substance, which we are calling a compound. So the first part of question 5, which is components of element and compounds, 3 elements and 2 compounds, has been drawn. The second bit is and state if it's a compound or a mixture? Is what we have drawn a compound or a mixture? The answer is, it is a mixture. Why a mixture and not a compound? When you talk about a compound, it will mean we cannot be able to separate. But when you talk of a mixture, you can be able to separate. So you have to separate the issue of this one being a component, which is a compound of the mixture, which is a compound, and the whole of the components together as a compound. So all the components, which are these two as compounds, plus these three, which are elements, they all form a mixture. But in that mixture, we have also compounds, meaning that those compounds can be separated and gotten as a compound on its own, the other compound on its own, the other element on its own, qualifying the whole of these as a mixture. And in doing so, we shall have explained by saying that it is a mixture because all the components, the 5 components, have different chemical properties, and because of the different chemical properties, they can be separated based on their structure or connectivity, qualifying what you have drawn as a mixture. We have been talking about chemical elements leading us to metals and nonmetals, which later on we have looked at them as forming mixtures and pure substances, which was coming from an element or a compound. How do you form an element or a compound, or for that matter, a compound which is a molecule? And we have qualified 2 main things in our today's lessons, that we have a pure substance and a mixture, and a pure substance encompassing small particles or particles that are in it that are of the same type, and a mixture encompassing small particles that are in it, but those small particles are of different properties, making them be able to be separated by physical means. That marks the end of our lesson today. Till next time, thank you.